I'm doing this because I will need every second I can get. I've not done this talk before, so hope we have fun. The talk outside and on the publicity and so on is risk analysis. And what I wanted to talk about today is stuff that you might be leaving out, stuff that might be missing from your risk analysis. So what's the trouble with risk analysis? Well, a lot of the time, testers are scared of things that have the word analysis in them. And so one temptation is to look for something easy that we can do. And so there's this traditional view of risk analysis that looks like this, which is risk is easy. It's just probability times impact, right? Probability times impact. But what does that even mean? There's no probability times impact. First of all, there's at least two kinds of probability that are important. One is like the roll of the dice, right? You roll the dice and it's got a 1 in 6 chance of coming up. But then there's another kind of probability, which is, I don't know, if something bad happened at Hogwarts, who's going to be behind it? Is it going to be Snape or is it going to be Harry? So those things aren't quantifiable. Those are essentially ways we believe that people will happen, but you can't put a number on that. That's just a guess. And then impact. Impact. If we're going to multiply stuff out, right, we better have a number associated with it. Well, what is the scale on which we measure impact? Some kind of, if it's a probabilistic thing, it's something between 0 and 1. So, but what's the scale of it? For how badly a problem affects a user? Well, what kind of scale do we put on that? How do we quantify annoyance versus harm versus loss? And then when we talk about how badly it affects the user, well, not very much software I'm aware of has only one user. Everybody who's using the software has different sets of values and different things that they would consider problems. What if just one person dies because of a bug in our software? Or what if just a few people die every now and again? Infrequently people die. What if a problem doesn't actually affect users at all, but hurts our internal people somehow, hurts our database administrators or our tech support people? And what if a relatively trivial problem becomes a huge news story? Now, a long time ago, in a galaxy far, far away, 24 years ago, I think it was, this whole incident happened, and I was working as a program manager at a company called Quarterdeck, and we made software that lived very close to the processor, in between the processor and Microsoft DOS, which was the big operating system at the time. Some of you may be aware of this story, some not. Those of you who are aware of this story, you have hindsight bias. You know how it's going to turn out. But for the probability times impact people, calculate the probability of this risk. So there's a known bug in the floating point unit of the Intel Pentium P6 processor, which was brand new at the time, and it returns incorrect binary floating point results through an operation on the processor called FDiv, floating point division, when dividing a number. And the bug is caused by 5 missing entries in a table of approximately 2,000 entries. What's the probability of this coming up? 50-50, very small. So that's quite a range, 50-50 versus very small. All right. Let me give you some answers that various people calculated. Intel claimed, because it knew about it internally, that a customer would experience this problem once every 27,000 years. IBM claimed that a customer would experience a miscalculation once every 9 days. Not a coincidence that IBM was making a competing processor at the time. Byte magazine, which was a big consumer level, this kind of for kind of geeky consumers, Byte magazine calculated that a 1 in 9 billion random floating point calculations would result in an error. Okay, given those odds, calculate now the impact of this risk, of this problem. Well, some of you know how it turns out, some of you won't. So let's go through the story. The bug was actually found in the processor, and it was reported internally by basically a kid, an intern, a co-op student who was working for Intel. Nothing happened. And then on October 24th of 94, a fellow named Professor Thomas Nicely, isn't that nice, reported the problem from the field to Intel. It was the first that Intel had heard about it from the field. November 7th, so 2 weeks later, a little more than 2 weeks later, a story appeared in Electronic Engineering Times, Intel fixes a floating point unit glitch. It's interesting because the story is about Intel fixing the problem internally, but not on the ones that had been, not on the processors that had been released to the field. 2 weeks after that, the story gets picked up and broadcast by CNN, and the story goes around the world. Just a month after that, Intel offers to replace all of the flawed Pentium processors that were out there in the field. And a month after that, Intel announced a pre-tax charge of $475 million against earnings. Just a little buggy wug, not a big deal. The sort of thing you'd see in, I don't know, Slack or LinkedIn, iTunes, something like that. So there's a big problem with risk analysis is, I think, the way we frame it is that we frame it in terms of, solely in terms of calculation in a lot of places, or at least that's what the books say, or that's what the syllabuses, the glossaries say, and that's what the trainers and consultants, some of them do anyway. They try to frame risk in terms of calculation, but risk isn't about calculation. Not if you want to connect it with the work that we're doing. If you wanted to build a risk model, you can get better, and use a systematic approach for it. So here's some of the things that we talk about sometimes. We talk about the risk gap. There's a product and we know stuff about it. We know stuff about its status. And then there's stuff that we don't know about its status that we need to know, we believe we need to know before we ship. So it's kind of like the range of our headlights. The purpose of testing is to close that gap. And the bigger the gap is, the harder it is to test. The more testing we need to do in order to close the risk gap. The more testability we need in the product in order to close the risk gap. The more information we need to gather, the more experiments we have to run, the more exploration we have to do. Now, over the last little while, over the last year or so, James Bach and I, my colleague, have been revisiting the way we think about risk, because we try to do this as much as possible to keep going deeper into our notions about risk. So one of the things that we've noticed is that risk analysis, like all kinds of analysis, really forms a loop. We start somewhere in the loop and we keep going around. We might identify suspected risks using heuristics, using our imaginations, using experience, by chatting with other people, by reflecting on those things. And if we don't have enough knowledge about that, our testing shouldn't be too focused. We need to do very open, very exploratory kinds of testing in order to do that. In fact, we have to do what we would call a testing to learn, surveying the product, playing with the product playfully, so that we can learn facts about it. And then, as we learn more stuff, we focus. We get ideas about where risk might be. We take suspected risk, and we try to link them to activities that would target them. And we frame those things in terms of perhaps test techniques, function testing and domain testing and stress testing and flow testing and scenario testing and claims testing and user testing. And automated checking. We set up automated checks in order to detect certain kinds of problems. And we roll most of our activities into that. And then we discover bugs. We find bugs and we find problems. And we find them, we know that there's a risk that the users will see them. So that turns the process of thinking about bugs into finding bugs, going from a suspected risk into a known risk, and then the cycle continues. So how do we go through that process? One thing we can do is to gather factors that would influence risk. And I believe there's a copy of this somewhere in the rapid software testing appendices. There are technological factors that go into our assessment of risk. There are ways that the project is set up that could drive risk. You know, if we're in a new domain, a kind of technology that the programmers have never been involved with before. There's a learning curve associated with that. There's new tooling we might have to think of. It might be, we might have problems associated with the fact that our part of our development team is here and another part of it is someplace else in some other time zone far away. So those are all factors that would influence our perception of risk. If it's new code, if it's brittle code, if it's old code, if it is complex code, if it depends on a lot of things, upstream or downstream, if there are a lot of downstream dependencies, all of these things are factors that would play into our assessment of risk and our evaluation of risk. And of course, how people specify the product, how they try to figure out what they want and what they can get, and how they might decide that they've got it, all of those things associated with requirements and specifications. And in fact, not just the construction of the specifications in people's heads, but the mapping of specifications onto models, into documents and stuff like that. One project that we were working on had a little problem because the fellow who was writing the specifications was not familiar with English, and he had this weird little habit. He would systematically forget to put in the word not. I noticed what happened there. There's this little ripple of a laugh, a giggle that went around the room. And what I'm going to suggest, I'm going to telegraph towards the end of the talk, that laugh, that ripple, is that the sound that we make when a light goes on in our brain, when we get an emotional reaction like that. We could take an approach of doing geometric risk analysis, mapping the product out into a space and asking, okay, let's see, when we're testing the product, let's try to think of what might happen if there's not something there that should be. If there's more than one when there should only be one. What about when there's lots of them, we have to manage them? What about boundary values and equivalence classes, a great favorite of people who think that all there is to testing is to say, just add one to whatever the limit is, or subtract one from whatever the lower limit is. We'll test that way. What about stressing things out? How far can we go? If we can start here, can we go farther? Can we go beyond the limits? What happens when there's something in between here and there? You know, there could be a lower limit and an upper limit, and yet behavior for the application might change in the middle someplace in ways that we hadn't anticipated, especially when we're dealing with signed mathematics and so on, so bit representations on the machine. What about monotonicity? Do things that are supposed to get big consistently get bigger? Do things that are supposed to be bigger, is that reflected in other places? What happens when we take an assumption that we've got about things and invert it? See, that's the difference between testers and regular people. The difference between testers and regular people is that we manage assumptions in different ways. We think about assumptions in different ways. There are assumptions in the world that are reckless. Some of them are risky. Some of them are safe. Some of them are obvious. Some of them are so obvious we don't talk about them. Like, I assume you're all safe because I assume all the chairs in here have 4 legs and those legs aren't going to fall off. If I talk about that as a possible risk for what could go wrong in this talk, people will think I'm nuts. But then there are assumptions that are safe. And that's the difference between testers and other people. We challenge the safe assumptions. We examine those assumptions to see just how safe they are. We could use general systems heuristics to analyze stuff. We could say that a condition that happens in the world with which our product is interacting, the human world and the physical world, that might happen rarely or frequently. A problem relative to our ability to detect it might be very detectable, or it might be subtle, or it might be hidden in various ways. A problem could occur in a process, or a problem could occur in a component, or a problem could occur in the relationship between 2 components, or it could occur in an environment, it could occur in a system somehow or other. And problems fall into lots of different categories, too. The heuristic test strategy model identifies a bunch of kinds of problems associated with things that people value: capability, reliability, usability, charisma. Do people like it? Is it a sexy, engaging, entrancing, aesthetically pleasing product? How about scalability, security, compatibility, performance, installability? What about internally facing quality criteria, like supportability or testability or maintainability or portability or localizability? That's what the heuristic test strategy model is all about. Those of you who were at the talk yesterday might have seen this. There are factors in our projects. There are ways that we can break down the product and apprehend it, looking at it in different kinds of directions in terms of its structure or its function or the data that it processes or the interfaces, the platforms on which it runs, on which it depends, or the platform that the product exists as for some other product. The operations that people perform with it. These are all places where risk can live. The interactions between the product and time. Risk can look in those places. And we can look for risk in those places. And these are elements of the product or factors of the product that we might want to cover with testing, because there could be problems in any one of those and in the relationship between them. And then there are the quality criteria that I mentioned before. Well, risk is kind of, I guess, a sort of inversion of the quality criteria, isn't it? Whenever these things are absent or diminished or unreliable, we could anticipate that there's a problem, that there's a risk. And of course, as I mentioned, there are a bunch of different kinds of test techniques by which we could explore risk. And we've talked about those sorts of things for a long time. There are also oracles by which we could recognize risk. And those oracles would include things like feelings that people could have about the product. That's a signal that there's something wrong. Or it could be principles of consistency or inconsistency with respect to familiar problems, our ability to explain what's going on in the product, to explain what we see, the relationship between the product and the way it models the world, the history of the product, the image that we're trying to present, claims that important people might make about the product. If the product is inconsistent with those, there's risk there. If the product is inconsistent with products like it, or with what reasonable users might want, kind of reflected in the quality criteria back there. If the product is inconsistent within itself, that represents a potential source of problems, which therefore represent risk. If the product is inconsistent with what regulators say the product has to be like, there's risk associated with that too. So we could take these things. We could take these things and use them as ways to recognize risk. You could focus risk ideas on one kind of problems. For example, as I suggested earlier, we could look for performance problems across the website, because those headlights can be directed or pointed in different ways. They're like the single headlight on the Tucker automobile. Remember that? I don't know if anybody seen the movie. There was a very innovative car being made back in the 1950s that had one headlight, but the headlight could point in the direction that you were turning the wheel, so that the lights would be pointing where you were going instead of just lining up with the car. It looked really cool. Or you could look at functional problems. Incorrect shipping calculations during the checkout. You could direct your risk that way. You could look for technical risk in a shallow kind of way, like the user might not get to the login prompt. So how would you check that? Oh, of course, you'd run a test for it. You'd look for the result. If it says you're not logged in, we're cool. If not, you report a message back via an automated check. Or you could think about technical risk more deeply. I brainstormed for about an hour the possible problems I could see in login. Because one of the things that annoyed me was every time you look at one of these blog posts on how to automate the product to do something, they always talk about, oh, well, here's a login example. And the login example they always give is really, really alarmingly trivial. Here's what I came up with. Authorized user won't be able to log in, or a user might not have access to resources the user should get at. No, the user might not be able to log in because he or she forgot the username or their password, or they forgot both, or maybe they're a new user that hasn't been set up properly. How do they get to find out about that? The user might have access to resources that they're not supposed to have access to. A user who's unauthorized might be able to log in. Now, that might be a hacker, or it might be somebody who was a legitimate user before and who kind of sort of by accident now gets to log in. Maybe the hacker will be able to log in by brute force or by social engineering or by some identifiable software vulnerability. Maybe the username or password will be intercepted in the middle of a transaction because it's going over the line unencrypted. Maybe the login fields will be vulnerable to known problems associated with security, stuff that's on the OWASP list. Or maybe the user will be fooled by a very credible looking site into revealing their credentials. Maybe the password information will be leaked because of a bug someplace else in the system. So I went on a bit for a little while. This took me about an hour of conjecture and research and exploration and play and looking at other stuff. And I looked at some of the things that were checkable and so on and so forth. So that's an option you can do. Anyway, that's what the whole map looks like. It's way too small to see. I can't even see it on this screen. It's in little bitty letters. So we could do that. Risk-based testing means organizing testing around risks that we suspect. Now, there are risks ahead of us that aren't covered by our headlights. Metaphorically, we would think of that as where the unknown risk is. But then there's also risk that could never, ever be touched by our headlights ever because we're facing forward and there's risk that we're not aware of. The unknown risk, the Donald Rumsfeld risk, where he said, oh, come on, there's known knowns and there's unknown unknowns. Well, it's important for us as testers to take unknown unknowns and move them into the realm of at least being known unknowns. And then off to the side of where we point the headlights, there's known low-risk stuff. We don't bother pointing the headlights at that because we know about it, but we perceive it to be low risk. If we target our headlights very, very narrowly, that might be the sort of thing that we do when we're investigating a specific bug. And if there's looking for a specific bug, and then there's a known bug, that's in that space there. And there's our field of suspected risk, all those places around where the known bugs are, and the things where there are actual bugs, not just suspected bug, but known bugs. That's known high risk for the business. But all this, it seems to me, is kind of abstract because it's all about technology and it's all about modeling stuff in a space. And so far we haven't really talked very much about the effect that this has on people. We mentioned a little bit with the oracles there, with the idea about feelings, but let's go into that a little bit deeper. Let's tell a risk story. Let's create a risk story. Some person or persons will experience a problem with respect to something desirable, something that they want, that can be detected in some set of conditions because of a vulnerability in the system. Now, how might that play out? Let's have a look. Some person, like a user, a customer, a developer, or a tester, or a person in the business, or a stakeholder or a stockholder, or somebody who's outside the realm of where we think our product covers. And those people, of course, could be plural. They could be represent a group or an entire business, a society at large, a community. I wonder if they were thinking about that back in those social media sites that appear to have been so wonderful at first, but that are, if we look at a systems view of the world, if we look at a McLuhanistic view of the world, what we will notice is that systems amplify whatever we are. So as much as they might produce good stuff, they can produce bad stuff too. So somebody will experience, in the context of some kind of event or some kind of situation, at least once, they will experience a problem that leads to bad feelings, to annoyance, to frustration, to confusion, to fear, to loss, to harm, or some kind of lowered achievement of value, some kind of diminished value that they might otherwise get from the product or from the system with respect to something they want, those quality criteria that I mentioned before. Well, if that's going to happen, we want to be able to detect it. Can we detect it? How would we detect it? By our feelings? By principles of consistency or inconsistency? Would those things be mediated by tools? Would we be able to see them by reference to something else, a specification, a diagram, a drawing, a comparable product of some kind? Because of a vulnerability in the product that we can detect in some kind of condition. So the vulnerability might take the form of a bug or a missing feature or something that only works occasionally, something that doesn't work all the time in the system. That's why if we're going to develop a model of risk, it's important to consider all these different factors, all these things that could make a difference and have an influence on how a risk turns into a problem, how a problem turns into a risk. So I was working with a group of testers, a couple of guys who were analyzing. They were doing what they called risk analysis, and I noticed that what they were doing was they were focusing all their attention on functionality. So I sat down with them one day, and we created this, which is to take all these things that I've been talking about so far and to put them onto a table. Now, we got to the parts in black, but then I thought it might be really important to think in terms of the last two columns. Who's affected by this? And how do they feel? Because there's another element to all of this, which is that there's a very important thing that I don't think gets considered very much when we're doing a risk analysis. And that is the effect that both the problems and the stories we tell about those problems, the effect that those things will have on people, on our stakeholders, the people that we're talking about risk with. So, it seems to me that in descriptions of risk analysis that we see that one thing that gets left out, it gets left out all over the place in the world of software, is how we feel about things, about feelings, about emotions. So, and James and I were just talking about this morning, instead of calculation, let's try construction. Constructing stories about risk. And construction of stories about risk are framed by all kinds of things. Our own experiences. Stories about risk that we've heard and that we take seriously because we see the impact of problems on people. That, in turn, is affected by how frequently we've heard those stories. Because of something called the availability bias. For years and years, especially 20, 30 years ago, people were terrified of flying because every few weeks they would see an airplane crash and people running out of a fuselage with their hair on fire. What they wouldn't see is the car accidents, those routine, mundane, everyday accidents that would kill people one by one by one by one by one. Lots of people are afraid of flying. Something on the order of 20, 30,000 people a year in the United States, if I remember the stats correctly, die in car accidents. For almost 15 years, there were no deaths on major commercial airlines in the United States. None, zero. And yet people were still afraid of flying, thought nothing about driving to work. We feel things about stories. They have an impact on us because they touch our emotions. And other people's feelings matter too. And how they care about other people. I think it'd be really interesting for us as testers to start to engage in the tools and the approaches of storytelling. Maybe that's because my first job after high school was in theater. I worked in a comedy club for a while there too while I was in university. And one thing that was really interesting was watching the way comedians get people to connect with stuff that they've never thought of before. Comedians and storytellers do that. Some technical risks may not feel like very much for some people because they don't feel like somebody's going to be hurt, or they don't care about the people who are being hurt. On the other hand, some people, because of the availability bias, may have exaggerated notions of risk. So here's a few examples. I'm trying to, just to see if I could nudge people's feelings a little bit. This is a conversation that somebody's telling me they're managing risk really well. We have 4,000 automated checks that we run on every build, and they all pass. Well, that's a good thing to do. That's a good thing to have. It's good to have automated checks that would detect certain kinds of changes. That's great. You know what product had 160,000 automated checks that ran on every build? Windows Vista. They bragged about that. Oh, there's that little chuckle again, the sound of an epiphany happening. So the response to that is, oh, and by the way, all those checks passed. Or they were dismissed as flaky checks. So the suggestion there is, well, maybe we should think about diversifying our approach to it. Not getting rid of the checks, but making sure that they don't displace other kinds of testing that we could do. Here's a story from Jerry Weinberg's book, Perfect Software and Other Illusions About Testing. It also shows up in his quality management series. And for me, it really gets down to, it really helps us to recognize people have different ideas about risk and what's important. Jerry was very upset. He was at one of his clients' places, and he was upset with them because he had heard of a bug that in their word processor that mangled the text of his niece's book. And the response he got from the product manager there was, "It's a rare bug. It's a rare bug." And Jerry says, "What do you mean it's a rare bug? It happened 25 times that I was able to find in her book alone." And the dude said, "Yeah, but it would only happen in a book-sized project. We've got 100,000 customers, and we probably didn't have 10 who took on a project that big. So, sorry, but she's only one of 10 people, and we got 100,000 customers." And Jerry says, "But she noticed it. It was her first book. And when it was printed, there were all these errors in it, and she was horrified and devastated." Program manager says, "I'm sorry, but it wouldn't have made any sense for us to try to fix a bug for 10 customers. And Jerry says, "Well, why not? You advertise that this word processor handles book-sized writing projects. And the guy says, well, we tried to fix it, but the features didn't work. And eventually, maybe we'll fix them one day. But for now, the chances are that we would introduce a worse bug, one that would affect hundreds or thousands of customers. I believe we did the right thing. Jerry's point in telling this story, and it's a really important story, is that risk always has a context. And he says, Jerry says in the book, I was conflicted because as a consultant, I didn't know what to say. I felt really badly for my niece, but at the same time, what this fellow was saying made sense. So quality, as Jerry emphasizes, and as we love to remind people, is not a property of the product. It's not something that's in the product. It's a relationship between the product and some person, or some persons who matter. And what that means is that decisions about quality are always political and emotional. Political because they're made by people with the power to make those decisions. Emotional because those people who make those decisions are not strictly speaking rational. None of us are. We don't make decisions based on facts. We make decisions based on how we feel about facts. And what that means is that our decisions about quality have to be grounded in ideas about whose values matter, who matters to us. So that's interesting. Decisions about quality are rooted in decisions about who matters. Now, it's not like you can't use numbers for risk calculations. This happened to me when I was a program manager at Quarterdeck. This was in 1996, if I remember correctly, and we were releasing a version of our memory management software, and I was getting reports from the testers that there was a bug, and the bug was in this particular disk controller, a disk controller that seemed to be out there at least. It certainly is one of our test systems internally. And our lead developer on the project, who had we had 3 weeks to go before release date, and our lead developer said, I got all these other things I got to fix. I can't fix this one, and besides, it's just Carla's stupid machine. He had an emotional reaction there too. So I went to the director of development at the time, and I told him about this, and the director of development says, well, is there a workaround? And the answer was, well, not really. It takes half an hour of walking through the process with a tech support person to get the system up and running again. How many users will this affect? I didn't have any idea. I mean, we didn't have a really well-functioning, statistically based market research department. I don't know. The controller's new in the market. I don't know how many things. We could call the distributors, I guess, and find out. And Larry very cleverly said, so what do we know? We've got a beta program. It's not a big beta program. It's a small beta program. But how many people in that program have that disk controller? I asked our beta coordinator. She said 3. Out of how many? 60. 3 out of 60. Okay, so 5%. 5% of the user base has this problem, or will have this problem when we release this product. But who knows how many controllers are outside the beta program? And Larry says, well, we're shipping 200,000 units. Suppose we're off by a factor of 10. Maybe it's 50% of our users have this disk controller. Probably pretty unlikely. Maybe 0.5% of our users have this disk controller. Do the math. That's as many as 100,000 support calls, or as few as 5,000. Because this problem happens, they're calling tech support. That's going to be guaranteed. So Larry says at a minimum, up to 5,000 support calls times half an hour. 2,500 tech support hours, and most of those in the first month after we ship. How many people do we have? 160 working hours a month. How many people do we have? We need 16 full-time techs to handle those calls alone. That was my response. Whoa. Ow. And Larry says, how many support techs do we actually have working at the company right now? 20. And there's still a 15-minute wait for people who call in most of the time. Customers are already frustrated. So to keep up, Larry says, we'd have to almost double our tech support staff within a month from now. So numbers can help us tell a story, but the numbers aren't the story. And Larry said, I'll get Dan to help fill out. I subscribe to Google Analytics reports on software glitches. Here's just, I picked them out about 15 minutes ago, just before the talk, 15 minutes before the talk. I grabbed a few of them. The 911 phone system goes down temporarily on Wednesday. A side channel attack lifts all the private RSA keys from our mobile phones. Bug led to permits for slaughtering animals, a goof up there. On e-bikes, there's a throttle software problem. How are these things making you feel? What's going on inside you as you hear these stories and think about somebody on an e-bike? A software problem deprives people of having their votes counted. A software glitch is connected to hundreds of foreclosures, people's mortgages being foreclosed so they lose their houses and their homes. So, what's missing from your risk analysis? Remember, we're making software for people. Problems affect actual people. Thinking about risk means thinking about people. Problems, how problems affect people, and the possibility that they'll affect people. And thinking about people means thinking about feelings, and not just about calculations, and not just about rationality. Thanks very much. Did I end early-ish? Like on time at least?
Yes.
Close to on time? That never happens. That's so cool.
We have 4 minutes.
Good risk management on my part, I'd say.
4 minutes for a question session.
They're very quiet, uncontroversial people. You need not be scared of me. I'm not. In fact, you know what? I'll even offer.
We have a question.
Oh, good. Oh, yay. Oh, jeez. As predictable as rain in Ireland. Hello, Roman.
Hello, Michael. Right on the back, I talked to one of the speakers too, and he said that such bugs like Windows Vista had a similar issues that count on release on iOS, and they tested well. We hope so. The thing that I was said, we cannot predict something. We don't want to test there. We don't want to test there. This part, we know that it always happens. We know that some bug is there, some issues may come there, and we don't want to take care despite we say this is not risk. Is it good position in general to think such way? We know that it will be in the interaction with people. Apple do this, Microsoft do this, everyone, big companies do this.
It's all about people. I mean, decisions about risk are not mathematical, they're social, right? So that sort of stuff gets worked out in social contexts. We have meetings, we have priorities. Developers are under pressure, so they have certain kinds of resistance to fixing certain kinds of problems. Developers have their own sense of risk and their own kinds of models of risk, and business people too, support people too. How do we sort that out? I say we just keep talking, right? We talk it through. But if we're going to be effective agents as testers, because that's what we are, we're instruments for the team to identify problems and risk. If we're going to be effective about that, it seems to me we've got to get good at talking about these things. Right? We've got to practice the construction of our stories and tell a story that has a connection to something that prompts feelings in people. That's how we become persuasive. That'd be my answer. I have, for about 50 people, a box of pens that I don't want to take back. They have hidden features, you know. They're a tester's paradise, these pens. So I encourage you to rush the stage and push people and clutch at them to try to get your pen. Are there any other questions? Yes, one over here. Great. Hooray.
Thank you for your speech. And the question is how to get the pen before the rush.
How to get the pen before the rush?
Yes.
Oh, sure, that's easy. Testers, when you ask for stuff, you get it. And if you don't ask, you don't get. Well, you might not get, but if you ask it, you up your odds of getting it. So see, wasn't that clever? Nicely done. Any other questions? Okay,
Ran out of
thanks very
time.
much.
Yes. Thank
Thank
you.
you.